Good morning. If you're just joining us, we will give folks another minute or two before we start here. Thanks for being here on time. Again, I'm seeing those attendee numbers clicking up there for all of you joining us. We will be giving it about another minute before we jump in here, so you can practice some deep breathing, do a stretch, whatever you need to do to be fully awake for this. I'm doing my best. It's 8 o'clock here on the West Coast. Not my normal time for being this alert, but I've had my second coffee and I'm rolling. Okay, I'm going to get rolling here. Hi, everyone. Welcome to today's Better Buildings webinar, dedicated to bringing you the latest actionable insights from leading industry experts. Better Buildings webinars are a chance to explore topics, technologies, and trends that affect your organization, as well as efforts to accelerate energy efficiency strategies and reduce costs. So let's jump in. Small buildings have a $23 billion energy waste problem. Buildings under 50,000 square feet comprise about 95% of US commercial buildings. They represent around half of energy consumption in commercial buildings. And in the main, they do not have controls. Having any kind of HVAC controls is the exception. We want to do something about that. So today we will be going over some details of a campaign that's sponsored by Department of Energy to attack that problem, that energy waste problem. We also have a featured speaker who is doing some really excellent work, far beyond the basics. I'm excited to talk about their work. For anyone there curious, we did have a second speaker lined up who is not able to make it today. That gives us a bit more time to delve into our featured speaker, and hopefully we can get Rick in a future webinar. So today's presenters, I am Elliot Crow. I'm an energy technology researcher at Berkeley Lab. I lead the Smarter Small Buildings campaign. And I'm happy to have Michael Blunchy here, who is from Department of Energy. He's the DOE lead on this campaign. We also have Marcos Rodriguez coming up as the featured speaker. Just before we jump in, I just want to invite Michael to say a few words just to tee things up here.
Thanks, Elliot. Hi, everyone. My name is Michael Blunchy. As Elliot said, I am with the Department of Energy supporting this work. I just wanted to say it's my pleasure to support this work, and working with this team has been really rewarding to see all of the amazing things that we're doing in the world of small buildings controls. One of the things we hear a lot at the DOE is that building controls are challenging to implement, that they don't work the right way. But we also simultaneously hear that that's one of the greatest opportunities for energy savings. So this is a very obvious thing for us to try to solve here at the DOE, just because we see such a great opportunity. Buildings often don't have controls, as Elliot says, and sometimes they have them and they're just not set up properly and they abandon them. And we are really trying to end that waste, which we think can be solved with just a little bit more support. And so we're happy to be a part of this team. So I'll hand it back over to Elliot to continue our presentation.
Thanks very much, Michael. And just want to note for all the attendees here, today's webinar is being recorded, will be archived on the Better Buildings Solution Center, and we'll follow up when today's recording and slides are made available. And go to that website as well. You can see a lot of past webinars as well on that website and find out what's coming up. Next up, attendees are in listen-only mode, meaning your microphones are muted. If you have any audio or visual issues throughout the webinar, please send a message in the Q&A box at the bottom of your Zoom panel, and our tech support team will be in touch. Okay, next slide, please. We have done the welcome. So the topics today, I'm going to give an overview of what we've been doing through the Smarter Small Buildings campaign, some of the resources available, some of the insights we've gained from that work. We then have a featured speaker talking about his excellent work at Bakersfield College, and we should have plenty of time for Q&A as well. So overall, we're talking about how improved HVAC controls can optimize building performance, reduce energy and maintenance costs, and really we say 10 to 20%. We've seen numbers far in excess of 20% in case studies. You know, we had conversations about what's realistic, and it potentially is higher than the 20%, but we thought people wouldn't believe us if we threw out numbers that high. But this is really a massive opportunity, and not only saving costs, but also enhancing occupant comfort is really important, of course. So next slide, we have a couple poll questions. If you follow the link here to slido.com, enter the code DOE. We'd love to hear who we have in attendance. We have one question, which is about who you represent. And then a second question talks specifically toward the topic that we're featuring today around small building controls. I'm going to sit on this first question here for 30 seconds or so. Just want to know who we've got in the audience here. A lot of contractors and consultants. And lots of others, the mystery other category. Local government. Yeah, it's good to see local government involved here. I think that I see a huge potential there. You know, city, state, county governments are, I think, in a really good position to benefit from a lot of these kind of controls. Public sector has shown themselves to be a great lead on energy management, so happy to see good representation there. Yeah, great, thank you. Let's flip over to the second question here and see how that's going. So this question, what is the greatest obstacle to implementing improved controls in small to medium buildings? It's not a quiz, it's a perception survey. Let us know what you think, whether you're coming from the perspective of somebody trying to sell these controls or a buyer of these controls. And cost is not surprising that is so often a challenge. Lack of an internal champion. That's a great one. I like to see that. I think I might be picking Marcos's brains on that. I think that is something that I've long thought is really key here. Identifying the right product. Yes, that's always a challenge. Too busy, too complicated. Dion, can we scroll down just to see what we're getting on for IT cybersecurity? Okay. I thought that would be higher actually, but I guess all the other things get in the way first. Okay, let's move on here to the starting presentations here. Right. Okay, back to me. Next slide, please. So I've made a couple of references here to the Smarter Small Buildings campaign. We've been running this for the last couple of years. It's all about packaged rooftop units. So small to medium buildings with those types of packaged units. They can be heat pumps, they can be dual fuel, conventional AC units. And of course, you know, why are we taking this focus? Most of the buildings in the country are small to medium. Only 5% of those have even smart thermostats. Some may be connected to a building automation system, but the numbers are really small. And as I've already mentioned, there's an opportunity to save very significantly on consumption and costs and improve comfort and streamline maintenance and extend equipment life. What's not to like about all that? Let's go to the next slide here. So what we do in the campaign is try and get people up this stairway. We currently are partnered with about 42 owner organizations participating in the campaign. We have 115 partners across utilities and technology vendors and HVAC contractors, industry organizations. And we're trying to collaborate to push the market forward. So as already mentioned, the majority just have these standalone thermostats. We have defined 3 levels of functionality beyond that. We don't necessarily believe that everyone has to get to the top step, but we think there's a lot of potential for anyone to get to at least beyond the first step. If we go to the next slide here, I'm going to talk through what we see in each of these. Status quo, programmable thermostat. Um, uh, I always think it's kind of funny to see these post-it notes, but I'm sure you've all seen them too. This is like building automation systems 101 is a set of post-it notes. Of course, you can adjust schedules and set points, and in our experience, mostly those schedules and set points are non-optimal. That's where a big chunk of the savings comes from just having schedules and set points right. If we go to the next slide, this shows us what we get. Just a network thermostat. If you can get controls accessible from a single point of access, a single dashboard that can connect to multiple RTUs on a single building, multiple RTUs across multiple buildings, all of a sudden you're able to monitor zone temperatures, set points, schedules across all of that from a single location. Great, for multiple RTUs and buildings. Just having schedules and set points right is, could get you that 10 to 20% alone. Of course, you need to get them networked. That's not always trivial, but we do think it's worth it and that there's a wide array of products available to do this. Next slide. Going to the advanced level, this kind of splits into multiple angles, economizer controls, variable speed fans, occupancy-based controls, optimal start and stop algorithms, demand control ventilation. All these are very well-established control algorithms and sequences, etc. Even though they may be not so common in small buildings, they're well established. They're not really cutting edge, and you may need to add some new sensors. You may have to add a bit of hardware, but the payoff is definitely there. And to the stat here, average whole building savings of 35%. There's a citation for that there. There really is high potential, and we worked a lot with UC Davis, University of California. They saw 28% savings from a mix of networked and advanced controls. So there's proof out there. Next slide, please. The optimized level, this is where it gets to be a little bit more cutting edge, grid responsiveness, coordinating multiple units so you can avoid setting new peak demands. That peak demand aspect of energy use is becoming a lot more important these days. And then some fault detection diagnostics. Some of these aspects are really the cream on top. Maybe they're more for high energy intensity buildings where you really get that bang for the buck. And as I mentioned on the advanced step, you may have to get some new hardware, some new sensors potentially. At this level, that also applies, and you also maybe need a bit of extra commissioning, monitoring, maintenance for the optimum controls, so it may not suit everybody. Next slide, please. So, as we understand it, most buildings are still at that bottom step, the status quo. We are providing technical assistance, resources, etc., to help get beyond that and help the market move forward. And you'll find more resources on our website all about that. Next slide, please. So I mentioned the campaign. If you follow the link, you can join as a participant. If you're an owner with buildings that you'd like to connect with us and see how we can help you, joining as a partner, whether that's technology vendor, contractor, industry organizations, and utilities, we look to collaborate with you, understand your challenges, see if we can connect the dots and support you with some R&D. Completely separate to the Smarter Small Buildings campaign, at Berkeley Lab here, we do also work under the Better Buildings banner on the EMIS technology research team, the tech team. So EMIS covers the full spectrum of building data analytics and advanced controls. So that's something where we meet roughly quarterly to talk about issues, whether it's large buildings, small buildings, or commercial buildings. Please reach out to me if you want to join up the EMS technology research team. Next slide. So, through the Smarter Small Buildings campaign, we do offer technical assistance. And here's some of what we've been dealing with in the last couple of years. The top 5 topics that come up in technical assistance requests that we get. Help selecting products that came up on the poll at the start of this webinar. How to engage stakeholders. So what this means is when there's an internal champion, that also came up on the poll, they need to convince their maintenance team, they need to convince their finance team, they need to convince the IT team. That requires a lot of conversations and a lot of understanding the various needs. So that comes up often. Operational best practices, how to go about implementing the right kind of schedules, how to set up optimum maintenance practices, etc. Item number 4 here, implementation, how to implement pilots effectively, how to sort of dip your toe in an effective way that's going to help you prove the concept and then expand from there. And then number 5, control strategies is obviously going to come up as well. A few quotes, I won't go through that, but this is just some examples of some of the questions that people come to us with, and we're available to all of you if you have questions too. Next slide. So I'm going to do a quick flyover of some of the resources we have developed in the campaign. These are all available for free at the website. If you want to go download these, if you want to reach out to us to ask more about these resources, if you have suggestions for other resources, please let us know. But for now, like I say, I'll do a quick flyover. If we can start on the next slide here, please. So first up, product selection guidance. I think it's maybe the 3rd time I've mentioned this here. This is a resource that we developed. It's a little bit of a, teach somebody how to fish kind of guidance. So what are some of the questions you want to be asking your internal stakeholders? What are some questions to ask yourself about what you really need in a product before you then start going out to technology vendors to ask them these questions of what capabilities they have. You can see in the bullets here, this is covering control capabilities, what kind of training and analytics you want, accessibility and IT, scalability, delivery model, and ongoing services are all covered in this product selection guidance document. Next slide, please. Next up, we don't claim to list every product that's out there. And also, importantly, we don't approve products. We don't endorse products. We're technology agnostic. But we know that for any of you that need to think about selecting a product for yourselves, it's not easy to find it. Just going out and doing web searches, it's hard to understand exactly what different products do because there's a lot of marketing speak. So what we've done is we've connected with our technology vendors. We created four broad categories of product and worked with technology vendors to kind of pop them into those buckets. I mean, there's a lot of nuance between products, but we've kind of tried to create some general categories And so we have a growing list. It's a living list. So whatever you find there today, we are constantly adding to that. So that is hopefully going to help you pick out specific products. And if we can go to the next slide here, please now. Okay, set points and scheduling. This is something which uh, seems simple, but when it comes down to it, having a specific internal standard for how you're going to set your set points and schedules is non-trivial. I don't want to make it sound too complicated, but I think there are a few top tips that we've established and vetted with the vendors of how to go about setting that up to get the optimum sort of energy consumption versus comfort balance. So that's a pretty brief document there for you. Next slide, please. Control guidelines. So this is something we actually developed in partnership with one of the participants in the campaign. They came to us and said, we're a state agency. We have our own internal guidance standard for more complex building system controls. That sets the minimum bar for any controls work that happens in our buildings. We don't have something like that for our small buildings. So if they're doing new construction projects, if they need to change something out, there was no guidance or minimum standards that they set internally for what those controls should look like on rooftop units. So we developed that for them. We then developed a generic version that you can use and adapt for your own purposes so that your organization can set the floor on what controls you want. So I won't read off what's on the slide here, but you'll see that the contents cover a wide range of aspects. This is a Word document format, so you just take this document, edit, and add to it as you see fit for your own internal needs. Next slide, please. Cybersecurity, boy, this is, as every one of you probably understands, is such an important issue. It's also very complicated. There are many guidance documents out there. NIST risk management framework is one that we come across a lot. That's pretty active in the federal sector. And it can be really complicated. And so for somebody, let's say an internal champion, an energy manager who wants to up-level their controls, add something that's going to be networked, you can't expect to become an expert overnight. You have an IT team that is very qualified. You have vendors who have a lot of qualifications, and you're kind of in the middle there, and you need to know enough to play in the middle of all those conversations. So we developed this relatively brief guide. It's all about setting your own internal requirements, how to interface with your internal IT team on this, what questions to be asking your vendors. And this was just released in the last month. As the same with all these resources, if you check them out, please send us feedback. Let us know what you think. I think I have one more resource to cover here. Number one question we get asked, again, this came up on the poll at the start, like cost is the number one concern. Relatively speaking, a lot of these smart thermostat networked controls are relatively inexpensive compared to a lot of costs that you might incur in a building. But until now, there hasn't really been any actual data on that. So we developed a few model test cases, like hypothetical building control scenarios. We connected with our partners in the campaign and asked them, how would you price this? Of course, there are many, many dependencies, but we were able to get some, rough costs for some different kinds of scenarios in that sort of network thermostat level, the advanced level that we saw in the stairway graphic earlier. So we now actually have at least a starting place for thinking about these costs. And, of course, there's often two elements to that cost, the purchase price and also the ongoing subscription costs. We have something in there about that. So I think this is something we hope to be adding to over time, because I think that's, like I say, there's not been anything on this before. We hope to be, building a more sophisticated view on how much these things cost. So that is the full lineup of resources through the campaign. I think that was my last slide. Let's see if we're now going on to Marcos. Okay, the main event. So, I talked a lot there about what's the industry baseline? I've talked a lot about the basic guidance and how to get you into this game and a lot of the guidance that we have. Marcos is an example of something who's gone beyond the basics. Marcos actually was presenting on a webinar last summer about some of the work they did just to introduce network controls. And I'm excited that he's returned today to talk about something that kind of goes even deeper. And pretty excited to hear more about this. So Marcos has led sustainability initiatives across Kern County's educational institutions, including Delano Union School District, Bakersfield City School District, California State University, Bakersfield, and Bakersfield College. And his leadership has resulted in millions of dollars in energy and water savings through diverse projects. Over to you, Marcos.
Good morning, everybody, and thank you, Elliot, for that introduction there. Again, my name is Marcos Rodriguez. I am with Bakersfield College. We are part of the Kern Community College District here on the south end of the San Joaquin Valley, those that are familiar with California. And we do have sister campuses in the town of Porterville, which is in Tulare County, and Cerro Coastal Community College out in the city of Ridgecrest out in the desert. And we cover about a 25,000 square mile boundary. So we cover a lot of ground. So nonetheless, I am the executive director for facilities and operations for Bakersfield College, all campuses. We have a total of 5 campuses. And I was a former HVAC adjunct instructor at Bakersfield College. I had tried that teaching gig once, right? And then I also attended Bakersfield College as a student out of high school. So it's kind of been a coming home for me. So hopefully this information I will share with the group here will be beneficial to all. Next slide, please. So a lot of things need to happen for projects to come together. When I was approached by Lawrence Berkeley Labs on a potential pilot demonstration project using these heat pumps, I wasn't really that familiar with them. We did have multi-story buildings on campus that used the heat pump systems, but they were well over 60 to 70,000 square feet. They run the Dicon systems, for those that are familiar with those systems, but we had never really done it on a small building. And so obviously a lot of this has origins with Senate Bill 350 that started back in 2018, 19 or so, where the state started putting together their energy goals for the future and what that would look like, obviously. And then just as a side note, Bakersfield College sits in Kern County, obviously, but Kern County produces about 80% of the oil in the state of California. So with that being said, we still need to meet our target reduction rates of carbon fossil fuels there. And with that, how we're going to do that is we got to try things, and that's kind of what led this pilots to get started. So working with Berkeley Lab, I just want to kind of give out some recognition to a couple of colleagues, partners there. We have worked with Richard Brown, who's now retired, Armando Casillas, Marco Bertoni, Dmitry Ratlatsky, and Donghoon Kim. So I've worked with several different people there. And then also they helped us on the technical side, put the project together, what kind of the basic guidelines, as Elliot stated during his presentation, what we kind of hope to expect. Of course, they helped us when we were having issues with things not working right, but that's part of the process. And then next, we were also introduced to work with the Best Center out of Cal Berkeley. That's Building Efficiency for a Sustainable Tomorrow Center. They're based at Cal. And so they're going to be helping us now with this establishing a curriculum using these heat pumps. And what will happen there as well, that we do currently have an HVAC instructional program at Bakersfield College. So a lot of the things that we're taking from these pilots, we're actually going to be sharing with our students, hopefully develop that workforce of the future. And, it's a win-win for everybody. And then lastly, our pilot site where this is going to be happening is our Child Development Center. It's an administrative building, and I'll get into the details on that later, but we'll go ahead and go to the next slide. Next slide, please. So as I stated earlier, Senate Bill 350, they wanted to talk about here in California how we've had issues with brownouts, blackouts. I can remember back in the early 2000s, for those that remember, we were having blackouts in power. At that time, I was working in production farming. And so we actually had to modify our irrigation schedules when we were irrigating out on the ranch and turn off pumps at certain times. And that's a lot of work. And think about it for commercial buildings as we keep building and adding buildings to the system grid. And without having that capacity there, the legislature, thought about the future and what that was going to look like. But more importantly, I think it's really important that when we try any type of pilot, that we need to be cognitive of what we're going to be doing and how that would work and try to meet the goals of the state here. They covered a lot of different things on, to reduce your load factor, and be able to diminish or shed energy during, especially demand response periods. Where we're based here, it's from 4 p.m. to 9 p.m. We're in a PG&E service territory, and Southern California Edison as well. And so this is going to help us kind of hopefully reduce that demand during that time. We're very fortunate that we do have 3.6 megawatts of solar power on our campus, at the main campus where this pilot was conducted. And then also we have a 752 kilowatt-hour battery energy storage system as well to help us with that energy triage of that demand response period. So, like I said, this is a learning process. I didn't come in with here thinking, oh, this is going to be something easy to do. We've worked through a lot of challenges and obstacles from suppliers delivering items in a timely basis to just internal things to work through with programming and security, but I'll focus on more. So just very quickly, if you kind of look at the graph on how power has been used in the state here and how it's going to be changing over time. For most that know that with solar production in California, if you can go back to maybe 2015, we had a pretty much horizontal use of power equivalent to what the solar that was being produced. Now we've established what they call the duck curve, where we have a large dip during the day with all the solar production in California. And then when the demand time comes back, it kicks back up. So we got to be able to flatten that curve, hopefully back to where it was in 2015, 16. And these are little things I think are very crucial in doing that. Next slide, please. So as Elliot stated, this is an open source program. The building that we work with for this Child Development Center, it's an administrative building. We used Johnson Controls for this building. It's their Facilities Explorer EMS system. And so we tied it back into the controls provided by LBL and how that was going to work. So we'll kind of cover all that in more detail. But obviously, heat pumps are non-gas operated. And that's what we replaced on this building. They were the dual fuel configuration, and these were the original building units that were installed in 95. And so again, the goal here is to reduce energy and to be smart about it, and more importantly, to learn about it, because as I mentioned earlier in the presentation, with the Daikin systems in the larger buildings, very different from the smaller rooftop units, as I'm going to be talking about here further. Next slide, please. So what I've done here is I've kind of put a couple of graphics on how this basic technology is going to work. Obviously, we have to take into consideration that, as Elliot mentioned, there was 42 other sites that have been working with this, and I'm sure everybody has had different issues or challenges. But I think thus far, the being able to predict how the system will behave is a good reference point or a template. And so that tells us that, you know, some of the things that we did or the modifications that we made were beneficial. And obviously this thing will take time, the optimization, the introduction of AI into the system and what that's going to look like. And in doing that, it's kind of been an interesting road. Sometimes, like I said, we've had some issues with the IT systems not responding accordingly, or we'd have to go back and reconfigure the system to kind of get the reporting tools back on. And so it's a process. And so the graphic to your right, it kind of shows how predictive controls of systems in a building or even outside, from EV chargers, water heaters, battery storage, thermal storage systems, and grid. And then also our campus also has a thermal energy storage tank system. So that's something we're hopefully going to be working with on a different pilot in the future as well. And so we're at a perfect time right now at our campus to bring all these technologies together and see how things will work. But again, it takes the group to put this together. And I'm really glad that we're able to work with the group. And before I forget, I do want to mention we are working with Peter Crabtree. They're at the Best Center there at Cal Berkeley as well. Next slide, please. So obviously there's different things that we need to be doing when we put these systems together, especially for the folks at LBL. We met numerous times with not only the researchers, but the equipment manufacturers. We worked with Melrock. That was the vendor of choice for the energy management, energy meter system, I'm sorry. And working with them, we went through several iterations of meetings to talk about how this was going to work, how they were going to be collecting data from us, how any IT security concerns that was mentioned earlier probably was the most difficult part for us to get through with our IT department, but we finally made the headway. And obviously, every scenario is going to be different. My understanding is that there was 4 testing sites in California. We were like Central California. There was a couple sites up north, and then a site based in Southern California. So every environment is going to be slightly different, but those that are not familiar with Bakersfield, you know, we regularly hit triple-digit temperatures on a regular basis. And so a lot of things can happen during those scenarios. But like I said, this is how you learn through these experiences, because nothing's ever perfect. Nothing will ever go as planned sometimes. And sometimes it does. We luck out. And like I said, but you got to be enthusiastic about the process. And when things don't go right, you know, we just got to find a means to correct those items. And then just on that right there as well, on the equipment dashboard, just kind of the graphics of what that project looks like and how that all kind of came together. We just have been monitoring now the building. Once we got all the real bugs worked out for about the last 8 months. So we're still collecting data. But the units were installed about 2 years ago. But like I said, it's just been a process to kind of work through everything. And so hopefully we're going to keep moving forward with that. So with that, next slide, please. So there was this process of working as a pilot. You know, there's a deployment stage and activity stage. So the deployment stage is the column to your left, and working with the different algorithms and, you know, having that demand response capacity for a project of this scale. I think Elliot talked about these small to medium-sized commercial buildings is the basic definitions of building under 50,000 square feet. And so in doing that, working with our colleagues to get this done. You know, they provided all the program parameters. You know, we don't have people on staff. We have a very small staff. I have a plant engineer and an HVAC technician that cover all 5 campuses for us. So we were very grateful that the teams were able to share their knowledge with us as well. Like I said, that middleware using the Rock platform, we're working with the factory representatives on that as well, in developing that platform and making that work, and into integrating that with our EMS system, as mentioned earlier. The retrofit of the pilots for this example, we had the conversion from the dual fuel to the heat pump systems. We had to actually go in, not only replacing the old units, but we also had to replace all the wiring to heavier gauge wiring for the new heat pump systems. We had to upgrade the EMS system. It was previously a pneumatically controlled system. So obviously going to the DDC system is the direction we're at now, and kind of has made it the campus standard. And so, and having, you know, the commissioning process of going through the whole exercise here. So it's really important that, like I said, when you're considering these, I call them pilots or experiments, that, you know, you're not going to think of everything. You cannot predict everything that may work right. And sometimes you can, just through repetition and whether people have experience and information that's shared, as such as this presentation, hopefully, that you're able to collect the information that you need. And more importantly, you got to have people that are inside the building that are even more collaborative, because you know, they're under a study. So, you know, we heard the occupants and they're concerned as well. And so I'll talk a little bit about that later. But again, it's a process, and it just a lot of repetition here, but having enthusiasm for the project is number one. Next slide, please. So the Child Development Center here, it was constructed in '95. As I mentioned, with the dual fuel units, we replaced 2 7-ton units. We replaced them with train units there as well. Again, this is an administrative operational building for our child development program. That's like for preschool instruction. And they actually have 3 centers where they actually have kids come into the campus and students work with them for the development of that program. As I mentioned slide before, we did have to retrofit the wiring on this building. We had to retrofit some of the EMS component sensors to upgrade everything from that pneumatic system that was in there. A lot of times we find out that stuff that we thought was working was not working. And so like I said, it was a good internal check to get these things corrected at this point. Fortunately, this project cost-wise was about $375,000. We were very fortunate that during the when COVID was around, there was for community colleges, universities, they had the Higher Education Emergency Relief Fund. That's how we were able to pay for this project, to replace these units, and with the addition of the bioionization systems that we use for COVID that were installed in these units as well, to take care of the cost of the project on that side. Next slide, please. So, as I mentioned earlier, replacement of the wiring, integrating the system into our energy management system for the campus. We did have to conduct pre and post occupant surveys. We're still waiting on the post occupant surveys to be conducted, but where we asked staff questions on just general HVAC comfort and what that looks like for them, and more importantly, what does that mean to them? And like I said, it's really important. And, you know, if you don't have people that are not cooperative, then it's a tough sell for the next time when you come up with another idea or another pilot to come back and ask, you know, will you sign up for a second time? So it's really important to work with your end users, and then also for our own staff. They learned things that they really were not accustomed to before, especially at this smaller scale. So we're continuing to learn that, and not only for our staff, but our outside contractors as well. We have an energy management system contractor that we use and based here locally, and they had to learn the system as well. So like I said, everybody had to put their thinking caps on and kind of be able to work through these issues as we develop them. And like I said, working with the lab as well, and making these things happen. So, you know, the goal here is hopefully, you know, we get to this automated grid responsive strategy over time and working through these issues as we've talked about. Hopefully one thing that we will look into the future is possibly maybe tying this back in a more direct way with the energy grid. So when the state ISO system, the independent system operator calls, you know, to reduce power in the state for whatever reason, that, you know, that maybe that would be something that could possibly automatically happen with this building, maybe drop it a couple of degrees. But, you know, if we're able to do that on many buildings on our campuses, then, you know, that could result in substantial savings. And if other people did it across the state, maybe that would prevent us from having, you know, brownouts in the future, that type of scenario. So, like I said, there's a lot of things to look forward with this project and to expand upon, hopefully, and we'll keep going with that. Next slide, please. So, as Elliot stated, and I know he didn't go over that 20% number, but with our demonstration here, we've gone up to about 42%, which is actually pretty good, and 24% over the winter. So it's really, we're very happy that we're able to get it to that point. And then the next part of this project is that we will actually end up having the BEST Center work with us to develop the curriculum for this program. And so hopefully the other issue is that just working through our sub-metering devices internally on the campus with our meterings for PG&E, our solar systems, and integrating those as well to the system. But with that, I think I'm at the end of my presentation. Hopefully you have questions. Elliot, I'll divert back to you.
Yeah, thanks so much, Marcos. Great to see that work. Yeah, and I'm going to look through the questions we've had. For any attendees, please go to Slido if you want to add some questions. There were a couple that were tagging your name specifically, Marcos. So I'm going to start with those. So the first one, do these HP Flex control systems work with microgrid controllers?
I have not done that. However, we are working on a microgrid project internally at the district right now. That's something that we may expand upon or explore in the future. I do not know if they do, but I'm going to assume that a lot of these systems, these components can integrate into the system. But again, I can't say that with 100% confirmation, but I would think that those will be integrated in the future as well as systems develop over time.
Okay, thanks. Okay, next question. You had a graphic that showed battery and thermal storage. Are you using both of those?
Yeah, so the graphic there was provided by Lawrence Berkeley Labs, and what that just demonstrated was the connection of different systems that can be dedicated to this HP Flex exercise. And so that's, as I mentioned on my last slide, one of the other challenges that we had was measuring the power. We could measure the power being generated, being consumed by the units, but I couldn't measure the power coming into the building for the building as a whole. So we're going to be installing some additional sub-meters. Hopefully, now that this building has its own sub-meter, we're going to be able to capture that data and see what that looks like. But the other project, as we look into the future, we're going to be tying our solar system back into that same building on the usage there. We're also going to be looking at the battery storage system as well. Our test tank system on campus does not connect to that building specifically. So those are self-powered, but we have other parts of the campus where we're going to be expanding upon that we have about maybe 40 buildings on campus that actually are powered by our test tanks, the thermal energy storage tank system. And we will hopefully capture that there. But all that picture illustrates is just a different equipment that you can possibly tie back to the system over the future. I haven't done anything with any water heaters or boilers on campus. We did a retrofit of an older building at our campus that had a boiler, but it's a heat pump system that we put in. And then just recently, we opened up a brand new campus in the city of Arvin. It's a one school building. It's 28,000 square feet, but that unit has 27 rooftop units that are net energy, net carbon. So we're able to demonstrate with a building on a much larger scale, and the system actually has worked pretty well. So these are things as we move along and what that's going to look like for other people to kind of learn from, and we talk to different groups all the time that come through and working with our students as well. And this is something that we're really focused, not only the experiments that we're conducting here, but sharing that information with our campus and our curriculum and the classes that need to know this information.
Great, thank you. I'm going to switch over and ask Michael Blunchy at DOE a question here. One of them seems well fitted to you. In what form does DOE Better Buildings offer assistance other than the guidance documents? Does this include funding, technical studies, energy audits, workforce development training, online calculators to assess savings, etc.?
Thanks. That's a really good question. Funding, I would say, is not the mechanism for the Better Buildings, but I will post a link in the chat for the Solution Center, which has a lot of the things that have mentioned there. Aside from guidance documents, there are plenty of case studies, fact sheets, a real wealth of information from all of the private and public partners that we've been working with and things that they've done. So showcasing a lot of the solutions that have been implemented. Another cool thing with Better Buildings is we will not be directly, giving funding opportunities, but we will see manufacturers of new products, be they controls or HVAC or otherwise, come to us looking for fields, for field validations, trying to find building partners that they want to test out new technologies on. And it's a great way to be on the cutting edge of that, in that we can partner with both those manufacturers and those building owners and connect those dots to do field studies of new technologies. So hopefully that answers your question, and I will leave the link to the Better Building Solutions Center in the chat.
Great, thanks, Michael. Back to you, Marcos. I'm going to paraphrase one of the questions here. Someone was asking about the overall reduction in price or energy costs. I think you're still kind of in the sort of maybe pilot sort of refinement phase, but I'll rephrase it as, have you done sort of return on investment estimates on what you would expect to be the payback for your work here?
We have not conducted that since we just recently started collecting all this data back to the system. I'm hoping after a year, we're going to be able to pull that data and start tying this back to the cost. Obviously, when we did this experiment, there was delays in getting equipment. We were coming out of COVID. We had like an 8-month delay in getting the actual units to the campus. So the hope is to kind of do that, to establish a number and see if that can be done. But at this time, that it had not been conducted at this point.
Okay, great. Thank you. Okay, there's a question here. I'll maybe field this and see if Marcos wants to add something here. So question, does your research show that health and IAQ indoor air quality lose out to energy efficiency gains when figuring out where to allocate energy and resources? My understanding is focus on health adds to operating costs. And I'll just kind of give my initial take on that I think that the number one thing maybe underlying that is the idea that if you are under ventilating spaces, then if you actually improve the control and actually give people the ventilation and the fresh air they need, then conditioning that fresh air actually has an energy penalty. You know, in my experience and looking broadly at this question, I think the overall gains of efficiency have far outweighed the potential downsides of that added ventilation. And of course, you know, we need our people to be comfortable. So I think that it's obviously really important. I think that I do not see that one cancels out the other is what I've seen in the research. Marcos, anything you'd like to add to that?
Yeah, that's something that's very challenging for us with outsider here in Kern County. Unfortunately, not that I'm proud of this, but you know, we have some of the worst air quality in the nation. We're always on the top 3 annually. We're always number 2 for ozone. So that's something that we continually have to work with, and you know, hopefully staff that, you know, as we over time, you know, you don't want to take on a lot of things at once, because then it gets very burdensome to individuals, and we want the experiences to be pleasant. We're doing everything we do to improve our air quality from the materials that we construct with, either during a modernization, during new construction, that kind of thing, but also, you know, the outside air that we bring into buildings. And so it can be a challenge, but like I said, that's right now, these are the things that we've been focusing more on the energy end, because obviously the cost of power in California continually increases substantially all the time. So
Yeah, thank you. I'm going to take one more question, and I'm wondering, with the questions we won't get to answer, if we could do some kind of FAQ we send out with the recording, but that's a side issue. So I'm going to take this last question. Where does adding AI and ML to these controls fit in? I think that's obviously a really hot topic. I'm curious, Marcos, if that's come up in your work there. I know you're working with the lab and with Melrock, very advanced organizations there. Has that come up at all for you?
I think people know it's coming. It's not like we're going to continue working. It's, you know, we're starting to see things across our campus that use AI, from operational machines that people would operate before, that kind of doing it on their own. I think you have to be open to it. You can't be afraid of it. It's really just dependent on the individual, but you know, I'm going to trust that the lab, and you know, from their experiences and the research that they do, that hopefully they're going to catch issues before they happen. But like I said, you just got to be open that not everything is going to work right every time, and you got to be able to have a contingency plan to correct that. Obviously, if I got a building and HVAC's not working and it's triple digits that day, you know, I'm going to be sending people home after it hits 80 degrees or 82 degrees, because we can't have them in the building. So it's really important that, you know, as we develop these, you know, be able to predict. Hopefully, my hope is that with this AI technology, you're able to, and this program here, that we're going to be able to predict behaviors of the energy baseline there, and how we can circumvent problems before they happen, being proactive rather than reactive on the backside.
Yeah, thanks, Marcos. Yeah, I was going to echo similar sentiment, that I think that you know, I think a lot of optimal efficient control is not rocket science, and doesn't necessarily need AI and machine learning. But I think that peak demand management is something which could really benefit for sure. So yeah, we're just going to wrap up here. Thanks again, Marcos, for your presentation. I think we have a couple slides in closing here. Just go back to the website, check out the upcoming webinars. I think I've got something to say about one of those webinars. Where is that? Okay, yeah, so the next webinar is Value Stacking Financial Metrics to Fully Assess Energy Project Impacts. This is going to present a holistic financial assessment framework and highlight partner experiences in leveraging various financial metrics to build a strong case for energy efficiency initiatives. Please go register for that. And with that, we'll just close up. And I'd love to thank again Marcos, and thanks Michael for being here today. Feel feel free to contact presenters directly with additional questions and check the chat for some of the emails and links that we talked about here. Thank you all very much and enjoy the rest of your day.